Here's an example. We want to evaluate the integral of x squared divided by the quantity 9x squared plus 1 to the 3/2 power. First, observe that we can rewrite the denominator as the square root of 3x squared plus 1 all to the 3rd power. If you like, you could do a u substitution, let u equal 3x, or we can just deal with the 3x here. I am going to build a triangle to reflect this situation. So here's my angle theta. I need one of my sides of the triangle to be the square root of two things added, so that must be the hypotenuse. So this side is going to be 9x squared plus 1, the square root of that. We're going to put the variable portion, the 3x, on the opposite side, and the constant 1 on the adjacent side. Then we can read off that tangent of theta is opposite over adjacent, so 3x over 1. Well, that means that x is 1/3 tangent theta. From here, we can take the derivative to figure out that dx is 1/3 secant squared theta, d theta. And from our triangle, we can read off that secant of theta is equal to the hypotenuse over the adjacent side, so that's the square root of 9x squared plus 1 divided by 1. Now we can substitute into our integral. The x on the top of this fraction turns into 1/3 tangent theta. Okay, because x is squared, all of that is squared. The radical on the bottom of this fraction is secant of theta, and that is raised to the 3rd power. And the dx is replaced by 1/3 secant squared theta, d theta. Now we're going to clean up a little bit. We have a constant, we have a 1/3 squared times a 1/3, so that's 1 over 27. Then we have tangent squared theta. We have secant squared theta divided by secant to the 3rd theta. So that is secant theta on the bottom of our fraction, d theta. Now we're just going to use a trig identity to help. We have 1/27 times the integral of secant squared theta minus 1 divided by secant theta, d theta. Then we're going to just split this into two fractions and reduce. So secant squared theta divided by secant theta is secant theta, then minus 1 over secant theta, d theta. This is what we had before I ran out of room. We can use one more trig identity to rewrite 1 divided by secant theta as cosine of theta. And now we can integrate each term. So we have 1/27 times the natural log of the absolute value of secant theta plus tangent theta minus sine of theta plus c. We have one more step. Remember, we did a substitution, so we currently have the variable theta, but our original problem had the variable x. So we can use this triangle to rewrite each of these trig functions in terms of x. Secant theta is hypotenuse over adjacent, so that's the square root of 9x squared plus 1. Tangent theta is opposite over adjacent, so that's 3x over 1. And then minus sine theta is opposite over hypotenuse, 3x divided by the square root of 9x squared plus 1 plus c.